welcome to our webinar. Today we have a guest. This is Victor Getz, and at first I will give the word to Ulrich.
Yeah, good morning also from my side, and thank you, Stefan, for the short introduction. My name is Uli Schneider. Somebody if you are following, for example, my hands-on blog article in the community. In real life, I'm working as a so-called customer success manager at the Open Telecom Cloud. And since a few weeks, I'm working together with Victor. Victor is, as Stefan mentioned it, it's a partner company from us. And our goal is to bring even a little bit more cloud native stuff around the CCE, our Kubernetes cluster, into the community. So that's all for the moment from my side, because it's 1 hour and it's short of time. I hope we can finish this in this 1 hour. Otherwise, maybe we need 2 or 3 minutes longer. So that's all from my side. And then Victor, it's your show.
Yeah, I'm very happy to have you today here. I wanted to show you today how we build a fully automated Open Telecom Cloud, some typical stack, and we will now march through everything to Terraform and stuff to get a very good working Open Telecom Cloud. Some words to my persons. Who am I? I'm a co-founder and cloud tech lead of EETS Consulting. I have 10 years of software development experience. I started with Java, and after some time I came into Kotlin, backend development, and at the last of the years I was then in the DevOps and architecture. Yeah, I'm currently designing big projects, cloud native architecture, and moving some lift in, not only lift and shift, but also to make them really cloud native compatible. And yeah, that's about what my history was. I'm absolutely crazy about automation. I don't like some manual steps. I don't like UI. I want to have everything as infrastructure as code. And I love it if some very complicated things is getting very easy, very simple. And so everybody can understand what's happening there. Two of my favorite books are Software Craftsmanship and Clean Code. And these are two books which I read very early in my career, and they really opened my mind about how also in the DevOps part you should just pay attention to clean code and software craftsmanship. One thing also to mention, I absolutely hate bash code. Like, I think bash code is totally ugly. It's totally not readable. So I prefer more like to have Terraform, or if it's really necessary, to go into Golang and to have some Go code. My favorite drink is gin basil smash. It is, gin basil. You smash it and you have a very good cocktail. So yeah, that's me. Some words about my company. I'm a co-founder of EETS Consulting. We were founded 2019. Our main goal was to have a company who have members which are very passionate about coding, which take it very seriously, and we provide agile development teams for cloud native automation of complex customer business processes. So we offer team as a service for like cloud moves and stuff like that. And yeah, we became very, very successful. After 2 years, we have already over 35 team members. And it's very, also for me, surprising to see how well our company grows. So what's the agenda for today? I want to talk a little bit about the cloud native landscape, and in the cloud world, what kind of technologies and frameworks are existing there? Which do you really need? After that, I want to go into Terraform plus Open Telecom Cloud, where we completely automate our Open Telecom Cloud with Terraform. We built some virtual private cloud, some Kubernetes CCE clusters, load balancer, and all the stuff you will automate with Terraform. And the third step is the Kubernetes step, where we then deploy some Helm charts. Helm chart is on top of Kubernetes, and then we deployed some Traefik, Work Adventure, JSON, all the stuff. And I think the cool thing is what we today will do. You start really from zero. We have nothing. Our completely cloud will completely be empty. You start from zero, and hopefully within now 50 minutes, we will be able to have a completely cloud and some certificates and some applications running there. Let's start with CNCF landscape. CNCF stands for a Cloud Native Computing Foundation, and it is like a collaboration of technologies and frameworks which are cloud native. And you see there's a lot of stuff is there, like many technologies. And somewhere here under members, we are also there, our company ETS, but there really a lot of stuff. For example, you see Kubernetes here, you see Helm here, all the technologies. And if you look at this landscape, you're thinking like, oh my God, what is happening here? And then you think, okay, I start a new project. What kind of technologies do I need? Do I need really all of them? Which do I need for my case and stuff like that? And today I want to clarify a little bit what the basic stuff is what you need. So the basic stuff is what you should need is some good cloud, for example, Open Telecom Cloud, which helps you to set up some Kubernetes cluster and all the stuff, and provides you some very good services out of the box. This is what Open Telecom Cloud does. Then my recommendation, this is everything just what I think is the right thing. HashiCorp Terraform you need. Terraform is the open source infrastructure as code software where you have something like an API for every cloud. So you can also switch clouds very easily and you can automate it very good. So you don't need to use ugly REST APIs, but you have some very good infrastructure as code structure to automate your cloud. And the third part is Kubernetes because it became the standard. Yeah. So I think currently if you go into the cloud, in most of the cases you build a Kubernetes cluster and doing stuff with that. So to have zero downtime deployments and scaling up and scaling down and stuff like that. These are some technologies. And what I wanted to also to say at the end today, I want to give you all also a list of technologies from the CNCF landscape, and you can vote which topic would be interesting for you. So in the next talk, we will then cover this topic which you are voted for. So the topic which got the most of the votes, then we will cover this topic then in the next talk. Because we have really a lot of projects, we have a lot of wisdom, and we are ready to share them with you. Yeah, we have also multiple projects with I don't know 400 containers plus. We have some petabyte projects also. So yeah, we're doing a lot of stuff. So Terraform plus Open Telecom Cloud. So I want to optimize my Open Telecom Cloud. Where do I start? What do I do? So what I wanted to show you today is a very basic, simple setup. For now, I would take the GitLab runner and I will get the access key and secret key from a vault system. Vault system is a secret storage system. We need access key and secret key from the vault system, which we will save the access key and secret key. They are from Open Telecom Cloud. The access and secret key you can get from the UI if you're creating some service account. And based on this, what we are saving in the HashiCorp Vault, we will get this then to the GitLab runner, and then we make plan and apply through Terraform. We'll set up our completely cloud. So we have multiple modules there. So we have some module structure where we say, okay, I want to have a cloud tracer, cloud tracing module. I want to have a key pair module. I want to have a virtual private cloud module. And then you put this module on top, and later you have your full cloud. So yeah. Talk is cheap. Show me the code. So I will now show you the code and we will start directly. So I'll go here into my project and I have a completely empty cloud. Here's nothing inside. And I want to optimize now over Terraform. So I go first to the identity and access management and will create myself here user. So one moment, please. Terraform showcase. I need to type in some emails. So what I did here, added here username, added the email address. So I will say, because it's some service account which we want to create, so I say here programmatic access, say next. I give him now full admin permission, say create, and I get my access key and secret key. So I have it here, access key and secret key. And what I'm doing now, I'm creating a project, some Terraform project. You see here also everything is empty. It's some empty project that just put some git ignore and some aliases here. And there are 4 environment variables which you need for automation. Like, it's my recommended way, but it depends how you want to use it, but we do it like that. So you have environment variable access key, secret key. You need the AWS access key ID and AWS secret access key ID. This is for the OBS S3 bucket. So because we will store our Terraform state inside Open Telecom Cloud bucket, so we need these 4 environments. These are very, very important for us. Since we have a HashiCorp Vault system, we will store all this information in the Vault system. So what I'm doing now, this access key and secret key, which I created here, I will take this one now and will save it under secret, OTC credential, showcase. Here I have my old access key and secret, and I will now just update them. So I say here, access key ID, we'll save it, create a new version, save it here. You can also do everything without Vault, but then it's not so convenient, and it's a little bit other working process. So I updated it here. So I have here my new access key and secret key. Yeah, it matches. And now just see here, it is under secret OTC credential showcase. So what does my simple bash script here do? It says here, this is my Vault system, Vault of Guardian of the OTC, this one. And I want to get now my access key and secret key. These are available under Vault, and then KV field, get access key and secret key. So what I can do now is I type here Cloud GUI OTC showcase, because I saved it under OTC credential showcase. What he will do now, he will go to the Vault system where I saved it. Then he will issue me a token by this one. So I get from HashiCorp Vault a token so I can access my secrets. And then what I have now, I will get now this access key and secret key as a variable. So if I make now echo access key ID, I have here now my environment variable. And now I can start working. So what I want to do first every time is to create, if I'm working with Terraform, I want to create a remote storage. So I want to have some shared file where our Terraform state is saved, because the Terraform state represents the state inside the Open Telecom Cloud. It's some kind of representation, what you want to do with Terraform. So I will also upload all the code. So later you can see also the code and look into that. So what I'm doing now, I will go to a different project. Git compare this branch. So what I'm doing every time, I'm copying every time the code from different projects, because we have a lot of projects, we have some module structure, so I can just reuse the code from different projects. And here I have some Terraform init. And this one, what it does, it creates me inside the Open Telecom Cloud, it creates me a bucket. So you see here, resource Open Telecom Cloud S3 bucket, TF remote state. You can look also in HashiCorp what the remote state is completely. But for now, we would just create this one bucket. So what do I need to change? Because I have a new cloud. So I'll go to variables. And here I type in my OTC domain name. This one is the OTC domain name, which you can see here. This one. And here you give your tenant name. It is the project which you're currently working. I have a sub-project which goes showcase, so I need to type here showcase. Then we have here the settings where you say I require providers. I need Open Telecom Cloud. And I have here my provider definition to define where it should go to. And here you can see that he's using here my access key and secret key from the environment variables, which I previously defined over my little bash scripting or bash aliases. I know I hate bash, but in this case, there was no workaround. So now we want to create this OBS bucket where we store then our remote state. So basically all the information which we create after that, it should be stored inside one OBS bucket. It should be registered who changes there something. It should be also versioned. So we will do that. Then we go inside Terraform init. And if you saw correctly here, some yellow line also. So he says you cannot locate the module because we bind here a module, and this module, what it does is gets the information from the environment variables. By default, it cannot access the environment variables. You can just have some predefined environment variables for Terraform. It's called tf-var and then underscore. If you export it like that, then it's possible to get the environment variables also, but you need to set such an environment variable with this prefix. But I will not do it like that because I use this environment variables also for the OpenStack CLI. And so if I would use in the OpenStack CLI the same variable with this tf-var prefix, then it would be totally confusing, because if I see an environment variable which is called tf-var, I'm expecting it's just for Terraform. And since I'm reusing it also for other CLI tools for the Open Telecom Cloud, I use global environment variables. So you see here, so there's some modules folder. And what I'm doing now, I will now add this environment module to the modules folder. Since it is some modules, so you can reuse them. I copied them also from different projects. And here, what it does, it just consists of, okay, get me the information from the environment. So this one is not yellow anymore. And now I can get my stuff from the environment variable. So what I'm doing now is Terraform init. What I would also highly recommend is please specify your Terraform version and also the Open Telecom version to one specific version, and not make it like that can be any version, because otherwise you will get some upgrading problems. Yeah. So I'll make now Terraform apply, and it should now create for me a bucket. But first, for sure, we need to say the stage name, because here's some variable stage name, and this defines the name of the OBS bucket. So in our case, we have showcase. So we enter it. And it wants to add here then the bucket. I'm very sorry, it's a little bit slow because my internet is very slow. So it takes a little bit more time than usual. If we go now to Open Telecom Cloud again, then we should be able to see here a new bucket. Here, there it is, TF state, showcase state. So this is the pre-step. Before you're starting with building a cluster, it is something highly recommended, and it doesn't matter which cloud you use, this step you need to do every time. So what we do now next is we go now into the showcase folder, and there we create all the stuff for our showcase cluster. So for our virtual private cloud mesh showcase and stuff like that. And it's also very important to have some very, very good understandable structure in your project, in your Terraform project. Otherwise, people will not see where they need to change stuff. So the basic structure, what you need to have is this one. So copy again code from another project. You need every time a main TF. The main TF is the red line through your whole project, to your whole cloud infrastructure. In the main TF, you need to almost use every time just modules and not a lot of resources. So everybody can just look and see directly what's happening there. This is very important. I would also recommend to put locals. Locals are local variables, and to put the normal variables inside some variables TF file. And then I would recommend also settings TF, where you define your required providers. Then you define here the provider informations. So this is the same as we had here in Terraform init. And then we have some main TF, which is the red line through all the stuff. But in the main TF, we will go step by step through. So what kind of stuff do we have in the variable? So we want to create a Kubernetes cluster, load balancer, all the stuff. So we need some local variables. The difference between variables and local is variables you can adjust from the outside, from environment variables, or from some command line interface. You can override these variables, but locals you cannot override them. So you know exactly that it's not changeable, some like final state. You would use locals if you know exactly this value doesn't change often and don't want to be influenced by the outside. So I have here some CRD range. I have here the name of my stage, so my cluster. What we are doing now is some very typical setup that you have 4 different virtual private clouds and 4 clusters, for example, development, QA, production, and some end-to-end tests where you test like the nightly builds. And this is one of these 4 stages which we are currently building. And later we'll also show you how you can easily switch this from one stage to another. You just duplicate the code and then you have a different stage also running. Here we have also the node spec, how many nodes we want to have. And the DNS we will not configure today here, so this one I will delete. This one we don't need. Then we have here the OTC domain name. This is again the number from the top right corner, which I showed you previously, our project name. And here I have some node spec where I defined here that I want to have 2 nodes I want to have. I think it's 16 GB of RAM, 2 CPU. And I want to have them for our clusters. So, and here, this is very important. Here we have the backend S3 storage where we store our Terraform state. Like in this Terraform init, we defined and created the Terraform backend storage inside the bucket. And here we just reference it. So here's the bucket name, and it's the same than this one. So we store now all the information inside one of our buckets, which you can surely also encrypt. So providers is the same, nothing changes, environment variables will be used. And then we come to the main TF. So what do we need for our cloud? I would like to have some cloud tracing services as first. So I can keep track of what people are doing on my cloud. So for example, I will now create some keeper and stuff like that. And I want to see who did it. So first I need the cloud tracing. For that, for sure, I will also use models because I'm a lazy guy. So just reuse what I have. And what does this module do? You see, again, same structure, main TF, variables, versions. Here you see, he will create an Open Telecom Cloud S3 bucket. It is a private bucket, and it will save all the tracing information inside this bucket. So you see here, we giving here the source. And yeah, one thing to mention is if you are using multiple projects, if you are having multiple clouds, multiple projects, and you don't want to copy all these modules every time. For example, we using then a shared module project. So you have one project where all the modules are inside there, and then you can just give here some, for example, GitHub link. So you say git add and then your address, and then you can just use this source, and then you don't need to have it locally. But for this showcase, it's way much more convenient and understandable if we just save it locally. So we have the cloud tracing service, and yeah, let's just try it out if it works. So we go into showcase. Terraform init. Now you see here he gets the S3 bucket, which we created previously. And then we say Terraform apply. So he says he wants to apply 2 things. So say yes, please. And if we go here back, and that was a misclick. Cloud tracing service. It's not done yet. Still creating. He needs a little bit of time. But this is the good thing about Terraform DevOps. You have a lot of time to go into Go coding or make some Helm chart, because Terraform code does a lot of stuff for you. So we will just continue during he will apply it, and we'll add a key pair also. So because we need a key pair, for sure we need a module again. So I will get a module also from a different project. So we have a key pair again. I need a virtual private cloud. It's every time very standard things what you need. So you need a little bit customizing, but in most of the cases it's very standard. And it is standard because you need to really pay attention to your code, to your infrastructure, to your architecture. Don't build something very complicated, because the things are very, very simple. Like also very, very complicated things you can do very, very simply. So we have here a cluster also. We want to have a Kubernetes cluster. So I'm getting here myself also the cluster module. The cluster module does a little bit more, because what it does, it also saves my initial kube control config inside one OBS bucket. So I can also get it from the OBS bucket. Then I want also have public access to my cluster. So it creates a public IP for us. It then creates my cluster and everything like that. It creates some hard disk storage, which are like very standard stuff. So then I add here my cluster module. Here I can also define which kind of flavor I want to have. I want to have 3 master nodes or just 1 and stuff like that. So when I have my Kubernetes cluster, for sure I need also a load balancer. So I'll also add my load balancer module. Again, I will just use the module. So we have here a public IP address. And yeah, then we have also a load balancer. And now it's the tricky part. We have some lot of information. We have some load balancer. Maybe we created a database. We have some passwords auto-generated over Terraform and added some users, configured the whole database. And we have a lot of secrets, a lot of information. And somehow I need to get my information from the Terraform to Kubernetes. So some of you guys were maybe thinking, yeah, okay, you just do it again with Terraform. Yeah, define your Helm charts, because there's a Terraform Helm charts provider. And then you can do everything in Terraform. But this is what I disagree with many people, because I think it's not a good thing to put everything inside Terraform, at least not in the same state, because otherwise you have some problems. Because, for example, deleting the cluster, then your state becomes corrupted, because Terraform still thinks that your Helm charts are somewhere running, but your Kubernetes cluster is already teared down. So you have some problems there. So what I try to avoid, to have some golden hammer where you just say, yeah, Terraform for everything. So I want to make a cut there. So what we are doing is we use then Vault. So at the end, when we created everything, we put our secrets inside a Vault. So it connects to Vault via this token, which I have now here, because I have some Vault token variable set by the bash script, which we are having. And then it will automatically add all the information which my Kubernetes cluster needs into the Vault. And then later Kubernetes will just get this information from the Vault system, and then we can work with that. So in this case, I need to keep control config securely stored inside our Vault system. And I need a load balancer ID also, because later the traffic and my ingress needs this load balancer ID. One thing to mention is this is the basic setup. This is not some high secure setup. So basically, if you want to have some role-based access control over your Kubernetes, so everybody gets a specific role, you do a little different setup, which is a little bit more complex because you need then, for example, a key cloak where you have some OADC connector. So you say kube control log in, you log into the key cloak then gives you the right kube control config and access for your Kubernetes cluster. But we will now just discuss the simple setup. So we need here again one module. It's called Terraform secrets. And we would just embed this then. So we put there the kube control config and the LB ID. And how does this model look like? So you have here a very simple resource vault generic secret. So you save it under secret. And then the stage name, which is in our case showcase, ELB info. And here also secret, showcase, kube control. Now we defined everything. And at the end, I want to have also the load balancer ELB ID just for showcase what the output is. Output is the output which gives you the information from your resource. So in this case, I will just print it out that we have a load balancer. So then I would just say Terraform init because we have new modules. Every time if you have new modules, you need to make a Terraform init. And we say Terraform apply. Oh, yes. So you see, there's a lot of stuff is happening here. 15 resources to add, and later he will print me out the load balancer IB. So I'll do that. And now it takes some time. It can take like 5-10 minutes. In the meantime, I will show you. Here we created the Open Cloud Tracing service. And now a lot of stuff should be happening here. So you see, virtual private cloud, one already. So make refresh again, maybe some new stuff is happening. Oh, CCE is already creating. So we have Elastic IP already. And so stuff is coming up online a lot. So in the meantime, during his applying, I want to discuss and show you some stuff about Terraform and some best practices which we learned. So what should we manage with Terraform? As I already discussed with you, I don't like it to manage Kubernetes and Helm with Terraform, but some people disagree and say do everything with Terraform. But if you do it, at least split it into 2 Terraform modules, so you have 2 remote states. You can manage Open Telecom Cloud with that. We are also managing Keycloak, Uptime Robot, GitLab secret environment. CCE is Kubernetes. It's the Kubernetes module, the Kubernetes as a service, which Open Telecom Cloud provides. And you can manage a lot of stuff with Terraform. And currently, we have just Terraform and this Helm charts, and it does like almost everything for us and for multiple clients. Yeah, you should not use Terraform every time, because if you have some not very well supported providers, for example, it has on GitHub not many stars, it's not so well maintained, I would advise against that. Then maybe it's better to use the REST API, which maybe hopefully the service provides. For example, we decided to go against Kibana dashboard to manage over Terraform because for us it was not very well maintained and not well documented. Some lessons learned. Terraform, use remote states. I see so often people using local states, and then they're wondering, oh, why can't I share it with my colleagues? Why this bug happens? Why this happens? And stuff like that. So use remote states. Pay attention to models. You saw how easily I can just add new modules and can reuse them, and we use them across multiple clients. We use the same modules every time. So it's you need to pay a lot of effort or like pay attention to your models that they're well structured. Main TF should be your red line through the cluster. If you're seeing here, you can easily see what's happening here. So you have cloud tracing service, key pair, virtual private cloud, cluster, load balancer. You have some Terraform secrets. So it's very easily to understand what's happening there. If you use the modules across multiple projects, put them in their own repository. It's with Terraform, you can very easily make some modules repository and then just use them in different projects. Also very important is keep it simple and stupid. Don't do like, oh yeah, I see there's some external provider. I will do a lot of bash scripting and then, yeah, so this is also what I sometimes see. So people overcomplicate Terraform and put some very specific logic into all this, yeah, bash code. If you need a high dynamic cluster creation, put the abstraction layer on top. So we have now a very basic setup. So if you want to have some, for example, production case, you just copy paste it, say here production. You need to change here some variables, and you need to change here one to say here production. With Terraform init, you create once this bucket, and you're ready to go. So you have everything here already. So you can just create production. But what if you want to have a very high dynamic cluster? So you want to scale it up and down just every day. And you have, I don't know, end-to-end nightly cluster, or you want to create for a customer which just needs it for 1 week or something like that. Then I would recommend you to optimize also this folder structure, which I currently have to template it completely. And then you can create multiple cluster, very high dynamic. But it puts also more complication and more stuff on top, which you need to know. So it depends every time on the case which you're having. I would also personally not recommend to manage Kubernetes with Terraform. Yeah, that's what I already said to you. So yeah, hopefully our cluster will now be up and running. So the second node is still creating. Oh, my internet's really slow today. It's based on your upload speed, and my upload speed is very bad. I'm very sorry for that, guys. So we need to wait a little bit more. So yeah, I will then explain you what we want to do today. So I want to host now in our Kubernetes cluster. I want to host a Jitsi system with Kubernetes, and I want to host a workload system, which then depends on the Jitsi system. And then we have some virtual environment, a working environment, which we can use. So it's again time for coding. During you will apply here. This is the good thing about Terraform. I would just go into Helm charts. Oh, we forgot one thing. We forgot the pipelines. I saved it in some branch. So how does the pipeline for Terraform look? It's very simple and easy. You have 2 stages, plan and deploy. So you go here inside the project, make Terraform init, make Terraform plan. We have here some SED for the secrets. If you by accident somehow expose in Terraform the secrets, it will then also replace it, so it will not be visible on your GitLab pipeline, so it not is visible on the UI. And apply is the same stuff, so you just make apply. Our pipeline looks a little bit more complicated because of the merge requests or pull requests. Then it becomes a little bit more complicated. It becomes also more templating because we have more clusters running. So we have here also before script where we say here, this is my vault system, which you should connect to. And then we have also some vault role ID and vault secret ID. This one is automatically created also via Terraform, but I don't want to go into detail because then we will not be finished today. It's Terraform is finished. So this is our public IP address, which is then accessible. And yeah, so we're doing the same stuff as bash aliases. And this is the normal pipeline which we'll use then for planning and deploying, just to give you some impression. So let's go to Kubernetes and let's go to Helm charts. So here again, I want to log into my newly created cloud. So I say here, use my bash again, alias, cloud GOTC showcase. It's the same command which I added previously to get my access key and secret here. So, and now this the new command kube showcase, and then I should get access to my newly created Kubernetes cluster. And voila, it was successful. To show you again what I did, I said this one. So I created the kube control config via Terraform, pushed it into the vault system. What I'm doing now, I'm just getting this newly created kube control config and push it into my local kube config. And there it will be stored. So I can say here, kube control get nodes. Newly created some seconds ago, very fresh. So let's bring up some services. What kind of services do we need? What do we want? We need, at first, I will compare it again with my branch. First, I use a Helm chart manager config. Helm chart manager config is the same as a Helm file, just an easier. It's some tool which we wrote because we didn't found a good tool which can apply a lot of services. Because when we are going to a cluster, we sometimes apply like 50 services at once. So we want to. We wrote for that. We wrote a Go script which then parallelize all the stuff and makes Helm use a little bit easier. So. This is based on Git. So what do we need? We need for our stage, we need custom resource definitions, because I don't want to have this problem because, for example, you have an application, you deploy it, but then you need, for example, some routing. But the Traefik has its own custom resource definition, Kubernetes custom resource definition. So your application depends on Traefik, because if you want to have the routing enabled for your application, you need Traefik first. So you build up a dependency, but the dependency only exists for this custom resource definition. I'll show it here. Prometheus we will not use for this case, but Traefik we need, because we use this ingress route here. So to avoid this dependency, so to have it independently deployed, we're putting all our custom resource definition in one Helm chart and manage it then in this single Helm chart. I will not go into deep with Helm chart because otherwise we will not be finished today. So what I will do now is I will just apply Helm charts apply minus charts. I will apply the CRDs first. So what he does is he goes and makes this apply command here, shows me the completely diff, what should be applied. And then I say yes. And it apply me the Helm charts like I defined here. So currently it's in default namespace. Yeah, it's something like Helm file. You can look at Helm file, but Helm file is very complicated in my opinion. It's not very easy to use. So I've applied now Helm charts, this custom resource definition Helm chart. And what do I need next? So if I want to spin up now some services, I will get the image pullback of error because I need to have some image pull secret defined. So in real customer case, we use a private Docker registry with Harbor and some custom resource definition interceptor, which then forwards every time when you're booting up some service, it automatically forward to our private Docker registry. But in this case, I would just use the image pull secret patcher. What this image pull secret patcher does every time when you're creating a service account or booting up some service, will periodically check if it has some service account defined, and then it will patch the secrets inside there. So here I will then also apply it. So there's some Docker config which will be auto-injected into all the deployments. So I say here again, Helm Cert-Manager apply -- charts, image pull secret patcher. On my GitHub account, this project is also hosted, and this project is from Titansoft Core.io. From Titansoft, sorry, not Core.io. And there you can see also how it works. So I am applying also this chart. And it's also done. So what do we need next? So we want to have some certification. And what we're doing here is, you see here, there is this Cert-Manager, and we want to deploy it in the namespace Cert-Manager, and we want to set also the ELB ID. And the ELB defined is here in the environment. So we go to the vault, and the previously stored ELB ID we will now get from the vault system, and we will use it now for our certification manager, because the certification manager needs the ELB ID. So we have here the standard Cert-Manager Helm template. So we have here the dependency to Cert-Manager. Yeah, exactly. Yeah. It's for all the anonymous user. So if you have some Docker account, then by default you need to patch every Helm chart, everything what you deploy. You need to set every time the image pull secrets. And that's why I use this image pull secret patcher, because it does it for me. It patches just everywhere my secret inside, but also where I defined which namespace and stuff like that, so I can also limit it. So this is my cluster issue from Cert-Manager to get me automatically certification over Let's Encrypt. Here I say my ingress class is Traefik, and issue a temporary certificate. I say yes, and here I put also the ELB ID, which the certificate manager then needs. So I'm doing the same stuff again, very easy. So I say here Cert-Manager, but this time I say -- debug, because I want to show you that he will also get the ELB ID. See here, now he prints me out directly what he wants to do. Cert-Manager needs the Cert-Manager as a dependency, so I need to say also -- update to fetch me also the latest Helm chart from remote. What Helm Chart Manager also does, it forces you to use Git. So based on your Helm charts, every time when it's deployed inside the cluster, it is automatically, the version from the Helm chart is set by the latest Git tag which you provided. So here, this one he wants to create everything, so we say yes. And this is a very cool tool. It's called Helm Diff. It shows you the difference between the current state of your Kubernetes and what Helm wants to apply. So you can see every time what's happening. So if we have some GitLab CI CD pipeline, then it shows you every time in the next release what should be everything released and what changes there are. So basically, I'm just going every time and look, okay, everything's okay. I just click on the play button, and then it applies me everything. So we have certification. And then I want to have some traffic. Here we need to set again the ELB ID. So I'm copying again the traffic module Helm chart. So here we have traffic here. Here I do the same. Helm charts manager apply traffic. Uh, 1.19 will also come shortly. Currently it's 1.17, but 1.19 will also come in some amount of time. So now I'm applying traffic, which then makes the routing for our services. So the cool thing is with traffic, you can have some custom resource definition where you can define the routing. So every application by itself defines how it should be routed. This is very cool for microservices. So keep control, get pods. Maybe we will get some image pullback of error. There it is. Keep control the pods. Because it just checks interval and it's not a custom resource definition injection. So it starts before the service account can be patched. But basically would say work around that if you will just use the private Docker registry. So we should have already a lot of pods up and running. Yeah. And its deployment was also successful. So we need to boost a little bit because time is running out. We want to have a Jitsi meet and the work adventure. So we have here now two Helm charts again. Jitsi meet, work adventure. We're doing the same stuff again. But this time I'm just doing Helm charts manager apply. And he takes every charts which are defined here in the showcase, because this is the current kube control config, and just looks if he should apply them. So we say yes. Tim, do you edit the EIP already for the domain? Because
yes, I did.
Okay, perfect. In the meantime, Tim added this public IP address to this domain because for this case I didn't have it on DNS name because yeah, I didn't have enough time. So we just used this guidance of the OTC DNS provider. So now let's see if he boots up. Again, some image pullback of errors, but it's not the problem. The pods just needs to deleting again. And then, oh, there's a typo. The question is, why do I have to do this? Because we're using every time private Docker repository, which we use then as a pull-through cache or a Docker mirror. I didn't want to adjust all of our Helm charts because we're using every time the same charts. So I was still a little bit lazy and used this image pull secret patcher, because if I would now set up a harbor system also and to make the pull-through cache and everything, it would just take too much time. So sorry for that. But I think it's not a problem. So he creates a container, and in the meantime, let's discuss some lessons learned. Kubernetes Traefik CRDs are super nice for microservices. I will also show you what they look like. For example, we have here work adventure. We have some routing, for example, for the front end. So I just say here host regex work adventure, and this pathway should be / or play. And then it should route to this Kubernetes service. So it's really, really cool. So you put the routing inside your microservice. So the microservice can really define everything by himself. You don't have some global configuration where you need to change everything, because otherwise you're going into the problem that you cannot be independent. So infrastructure would be very tightly coupled with your microservices. Manage your own storage class, just some tip. If you take it seriously, you should really manage your own storage classes, not take the default storage classes, because by default, I think it's the retain policy is delete. So basically, if you delete your Helm chart and your PVC, all the data is lost. So it's very good also to manage your storage class, because sometimes you need SSD, sometimes NSFS. So it's really good to manage your own storage classes. One thing also is 12-factor app. This is a very, very good guideline how you should make microservices and how you should treat cloud. But we want to see if our cluster is running. Kube control, get reports. We need to see if our certificates got valid. Git control get certificate -a. Woo! We got already SSL, so let's try it out. What do we want to try first? Work Adventure for sure. Zack. Here's Work Adventure Showcase Guardians of the OTC. Voila! It's working. I type enter. It's slow today. So I can run here around, and it's a very cool tool for virtual office. And then I can sit here on the sofa. Oh, Uli joins me also. And normally here Jitsi opens, so we have also Jitsi connected. It's working also. Yeah, and then we want to also test out Jitsi. Jitsi. Oh wait, I will just copy the URL from here. So Jitsi. So we can say here also some meeting, and we are in chat Jitsi. And this was a lot of work to get Jitsi running, because currently there is no working solution for Jitsi for the Kubernetes environment. So we had to provide our own chart and worked around our own Helm chart. It will become public in, I think, some weeks. So it is then open source for all you guys available. Yeah, we are done then. We have applied a lot of charts. Just take a look. You want to get all -a. This is all the stuff which we applied already. A lot of stuff within 1 hour. And we are also finished rightly in time, because now it's 11. And now we have some 5 topics which I wanted to present you, in which we have also very deep knowledge, and you can vote which topics you are interested in. So this link will be also posted in the community dashboard. And yeah. If you have some more questions, or if you need some support for your Kotlin application or Vue.js application, or some cloud moves, just give us a call and we can help you for sure. We have a lot of technologies and ready to go stack, so we can help you very easily to get it done very good in the cloud. And yeah, I hope you liked it. Here's also the link to our community dashboard. You can also follow us on Twitter. We have there also a lot of stuff. Yeah. So that was it for me. Stefan, you will take over? Or?
Yes, thank you a lot, Victor, for this really, really cool 1 hour, packed up with a lot of information, and also when you look into the chat, a lot of great news, great discussion, everything. For you, I also put the link into the chat for the voting for the next session, so please use this this possibility here, because the mostly voted element will be our next topic, our next webinar here, together with Itz and most probably also together with Victor again. And with this, I will say thank you all of you who have joined the session today. I hope you have enjoyed it, and see you next time. When you want to stay up to date, just register in our community portal. There we will always upload the new webinars. Thank you a lot, and wish you already a nice weekend. Bye.
Thank you. Bye.